Okay, hi, scholars, geometry kids. We're going to go over section 5.5 today. I alluded to it today when we were in class together. We have two theorems that we're going to talk about, and we'll do a couple of examples. So have these notes along with you. You could also have your student journal open because they're printed in there. And then everything that I'm going to show you here on this dynamic classroom corresponds to your book as well. So if you want to have you're one of those people who want to have your book open and see these examples as we go through them, feel free to do that also. The vocabulary you'll need to know for the side, and hypotenuse leg theorem are legs and hypotenuse. So in a right triangle, the hypotenuse is always the side that's longest across from the right angle, and the legs are the other two sides that form the right angle. So the legs are always like this, and the hypotenuse is always across. Otherwise, we did talk about congruent figures and how to map them onto each other with a series of rigid motions. So we're just going to go through these congruence theorems. Theorem 5.8 says that if three sides of one triangle are congruent to three sides of a second triangle, then they must be congruent. There's the only way that can happen is if AB is congruent to ED, BC is congruent to EF, and AC is also congruent to DF, and they are in their corresponding parts. So that means if the two triangles are congruent, that means it's the only way that can happen. The angles are also congruent. Every corresponding part in each one of those triangles is congruent. The proof here is, remember we talked about if you can do a series of rigid motions, transformations, to map the one onto the other, then they have to be congruent because rigid motions preserve congruence. So if you started with these two and you want to prove that they're congruent, first you scoot this one over so that A and D match. Then you end up with this picture right here. And then what you're going to do is you're going to take the C prime and you're going to rotate it over here so that the whole thing switches over so the C prime matches the F. That's what this purple arrow indicates. And then you have this shape. Now we've already proved a number of times that this shape is congruent. And so there's a paragraph proof here about it, but this is previous knowledge. So you should be able to see that those two map exactly onto each other. Now, if we want to use this theorem, this is really only a three-step proof, even though they put 1 and 2 together, and this is how we do it.
Write a proof. Given that segment KL is congruent to segment NL and segment KM is congruent to segment NM, prove that triangle KLM is congruent to triangle NLM. Solution. Write a 2-column proof. You are given that segment KL is congruent to segment NL. This is one pair of congruent sides. You are also given that segment KM is congruent to segment NM. This is a second pair of congruent sides. By the reflexive property of congruence, segment LM is congruent to segment LM. This is the third pair of congruent sides. Now, notice that you have shown that three sides of triangle KLM are congruent to three sides of triangle NLM. So, by the side congruence theorem, triangle KLM is congruent to triangle NLM.
And that's it. It's a very simple, straightforward proof. But again, for 1 and 2, I would have put them on the same line and I would have made it 3 steps. Here's an example. When we do this under the camera or when we're live, this is for, me to ask you some questions, examples. But here is a real life problem with just an example of why benches have crossbars.
Explain why the bench with the diagonal support is stable while the one without the support can collapse. Solution. The bench with the diagonal support forms triangles with fixed side lengths. By the side congruence theorem, these triangles cannot change shape, so the bench is stable. The bench without the diagonal support is not stable because there are many possible quadrilaterals with the given side lengths.
And that's it. 30-second explanation. Again, this is to ask more questions, but that's basically all it is, using the side, side, side. So if you get two different figures, you can match them up. Okay. This part that if you have opened your book, you'll notice it says construction. It's if you have one triangle and you want to construct with a straight edge and a compass, it shows you how to do the other one. We're not doing really our constructions. If we were in the classroom together, we would. If you'd like me to show you separately, I'd be happy to show you how to do it, but otherwise we're going to skip this part. Okay, now we have one special case because, now that we've talked about side angle side and side side side, and they're valid methods for proving triangles are congruent, you might think to yourself, well, what about side side angle? Like, is that something that would work? Generally, no, because here's a single example where, remember, you only really need to find one example that does not work in order to disprove something. So here's an example where AB is congruent to ED, angle A is congruent to angle D, and BC is congruent to EF. But clearly those two triangles are not congruent. So while it's not valid in general, there is a special case if it's just a right triangle. So if you have a right triangle and you get the hypotenuses congruent and then at least one of the other sides, then we have something called the hypotenuse leg congruence theorem. And so it basically says if you know the right triangles and you can get one of these legs and the hypotenuse, then bam, you've got that they are congruent. It could be either one of the legs, but it can't be like AC congruent. It's got to be the same corresponding side. So here's an example, and I really like this because I've mentioned the orientation a couple of times. So this is another one for 2 minutes here.
Write a proof. Given that segment WY is congruent to segment XZ, segment WZ is perpendicular to segment ZY, and segment XY is perpendicular to segment ZY, prove that triangle WYZ is congruent to triangle XZY. Solution. Redraw the triangles so that they are side by side with corresponding parts in the same position. Mark the given information in the diagram. You are given that segment WY is congruent to segment XZ, segment WZ is perpendicular to segment ZY, and segment XY is perpendicular to segment ZY. If you have trouble matching vertices to letters when you separate the overlapping triangles, leave the triangles in their original orientations. Now write a 2-column proof. You are given that segment WY is congruent to segment XZ. Notice from the diagram that these segments are the hypotenuses. You are also given that segment WZ is perpendicular to segment ZY, and segment XY is perpendicular to segment ZY. By the definition of perpendicular lines, angle Z and angle Y are right angles. Then, by the definition of a right triangle, triangle WYZ and triangle XZY are right triangles. Next, by the reflexive property of congruence, segment ZY is congruent to segment YZ. Each of these segments is a leg of one of the right triangles. Now, notice that you have shown that the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of the other right triangle. So, by the hypotenuse leg congruence theorem, triangle WYZ is congruent to triangle XZY.
And what I was saying about the orientation is some of you are really good at taking these two figures apart, WZY and XZY. So if I was just going to separate these, I would take this triangle and redraw it over here. And if you can, put them in the same orientation. So make sure that the W and the X is in the same place and the Z and the Y. And if you can't, that's okay too. Just redraw it like this. So that's just an example of how to do that. Here is an example where if you have one right triangle and you can prove the other ones, the picture's not great, but this is a good example of how to use the hypotenuse leg congruence theorem. So here we go.
The television antenna is perpendicular to the plane containing points B, C, D, and E. Each of the cables running from the top of the antenna to B, C, and D has the same length. Prove that triangle AEB, triangle AEC, and triangle AED are congruent. Given that segment AE is perpendicular to segment EB, segment AE is perpendicular to segment EC, segment AE is perpendicular to segment ED, and segment AB is congruent to segment AC, which is congruent to segment AD, prove that triangle AEB is congruent to triangle AEC, which is congruent to triangle AED. Solution. You are given that segment AE is perpendicular to segment EB, and segment AE is perpendicular to segment EC. So, angle AEB and angle AEC are right angles by the definition of perpendicular lines. By definition, triangle AEB and triangle AEC are right triangles. You are given that the hypotenuses of these two triangles, segment AB and segment AC, are congruent. Also, segment AE is a leg for both triangles, and segment AE is congruent to segment AE by the reflexive property of congruence. So, by the hypotenuse leg congruence theorem, triangle AEB is congruent to triangle AEC. Now, you are also given that segment AC is congruent to segment AD, and that segment AE is perpendicular to segment ED, which means that angle AED is a right angle and triangle AED is a right triangle. So, you can use similar reasoning to prove that triangle AEC is congruent to triangle AED. So, by the transitive property of triangle congruence, triangle AEB is congruent to triangle AEC, which is congruent to triangle AED.
So I know it's very wordy, but hopefully when the little marks were being made, you could follow that along. If you couldn't follow it, stop and rewatch it. Okay. But, for 2 minutes, this is a great example of where you could use a paragraph proof instead of a 2-column proof with statements and reason. And that is a perfect example, something like that. You'll have some examples like that in Big Ideas. Again, this is monitoring progress, and the assignment has 40 exercises. I believe I assigned 20 of them. Okay, so you have a few days to get that done. And of course, I'll be helping you along, and let me know if you have any questions.